All right, we're going to go ahead and take a look at example 2 on lesson 3.5. This is systems of equations. And here we're going to compare two taxi services. Service A charges a base fare of $5, and then it's $2 per mile, where service B is $3 for the base fare and $2.50 per mile. So here we have clear start values. $5 and $3 are clear start values, and this $2 per mile and this $2.50 per mile are clearly rates of change. So from that we can write the equations. Y equals, for service A, it is $2 per mile, so that's going to be 2x plus the start value of 5, where this equation is y equals 250 times x plus the $3 start value. So for these, we're going to go ahead and just number our tables 0 to 5. And from the equations, we don't even actually need the equations, but from the equations we should be able to figure out what these are. Our start value here is 5. Our start value there is 3. This is increasing by $2, so it's 5, then 7, 9, 11, 13, and 15. So we have a nice table there of values. If we go to this one, this is $3. So, and we're adding $2.50, so this would become $5.50. And if I add another $2.50, that's $6, $7, $8. Add another $2.50, that is $10.50. Add another $2.50, that is going to be $13. And add another $2.50, that is $15.50. So is there a number of miles where the cost is the same? If you're looking at the table. Yeah, 4 miles is $13, right, for either service. So we do have a place where the lines are going to intersect each other. Let's go and turn to the page and take a look at the graph. So for this one here, I think we can just go by ones. These numbers are really pretty easy. 1, 2, 3, 4. That's where the intersection is, right? 5, 6, 7, 8, 9, and 10. Here we'll just go up by ones. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's correct. There should be 20 lines. So you should end on 20. Now what were the equations? For the first one, it was 2x plus 5. And on the second one, it was 2.5x plus 3. So those are our two equations. Let's graph this first one. This is going to start at 5, and it's going to increase by 2. So that'll be 2 up, 1 over, 2 up, 1 over, so 2 up, 1 over, 2 up, 1 over, and just keep doing that all the way across the graph. Now the other one starts at 3. So this one's a little bit tougher because it's not going by even increments. But if I look here, there are some nice points I could put on here. 0, 3 is obviously the first one. I could put 2, 8, and 4, 13 without having any decimal values. So 2, 8, which is right here, and 4, 13, which is right here. Now how much am I going up? 1, 2, 3, 4, 5, and then 2 over. 1, 2, 3, 4, 5, then 2 over. That does put me there. I could continue. 1, 2, 3, 4, 5, 1, 2. That puts me over there. So once you have an idea of what that slope is, you can use it. There we go, right there. And for this one, there we go. And this intersection right here, oh, no, it's this one. Sorry, I went too high, is 4, 13. So once again, when you make a graph, you do want to label where they intersect. Now, could we use the same method we used in the last problem to find this intersection of 413 using just the equations? So we're going to do the equal values method. So we're going to set these equations equal to each other. Once again, I like to take the one with the bigger x term, so 2.5, I'll use that and put it on the left side, and then the 2x plus 5 goes on this side. So we have the two equations equal to each other. Now it's just flip, combine, divide. So what are we going to flip? I want all the x's on one side. I like where this 2.5x, that's fine. This 2x flips, becomes negative 2x. Bring down the equal sign. This 3 should flip, so we'll make it a negative 3. And that 5 just stays there. Now we can combine. This is a 0.5x. And if I combine those, that is a war. I have 2 left over. And then as my last step, I'm going to divide by 0.5 to both sides. That cancels, and we're left with x. This, when you divide 2 times 0.5, the answer is 4. Let me explain why. If I have 2 sandwiches, and I'm dividing them into 0.5s, how many 0.5s do I have? 0.5s is like half a sandwich. So if I cut these sandwiches into halves, how many halves do I have? 1, 2, 3, 4. So when you divide by a fraction like 0.5, you're actually making the total values bigger. Because your question is how many 0.5s or how many halves are in 2? And so we can see there are 4 halves, right? Each sandwich has 2 halves, so the 4 is the total. All right, and then we can confirm the 13 by plugging this back into either equation. I'm just going to do the first one because it's simple, right? So 2 times 4 plus 5, that is 8 plus 5, which is 13. If you want to go ahead and confirm that if you plug 4 into this equation, you also get 13, you're more than welcome to. All right, so that is the end of example 2. So the next video will be example 3.